Hey everybody, this is Ms. Mo. This is 9.1 notes. First, before we get started on the fill in the blank notes, let's turn it over and just write some vocabulary that we are supposed to have already known. Okay, and most of these you know. So and you don't have to write all of these down because some of them are obvious. Okay, so even numbers, we know what those are. 2, 4, 6, 8, blah, blah, blah. Okay, we know that. Odd numbers, those are numbers that are not divisible by 2. So 1, 3, 5, blah, 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 blah. Okay? Neither is the number 0. Okay, now that we have that, let's talk about prime. Prime means only the number itself and 1 can divide into your stuff. So, like the number 3 and the number 2 and the number 5, these are all prime because nothing can divide into these except for 1 and itself. So like for this 5, the only thing that divides into a 5 is a 5 and a 1, or a 7, or a not 9, not 10, maybe 11 or 13. These are prime because only 1 and the number can divide. So 13's prime because the only thing that can divide into 13 is the 1 and the number 13 itself. Okay, composite means more things can divide besides 1 and the number itself. For example, the number 4. You can divide that by 1 and the number itself, 4, but you can also divide it by extra numbers like 2. Or another composite is 4, 5, 6, 7, 8, 9, 10, not 11, 12, blah, 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 blah. And these are composite because we can divide by 1 and the number itself and extras. That's what composite means. You can divide by the number itself, like 4, the number 1, okay, and extras. So the extra would be a 2 that we could divide by if I was looking at this number 4. Okay, neither prime or composite is the number 1. Yeah, okay, we're going to need to know that later. Okay, when it comes to how we write our answers, we're going to see the word integer in our homework. Integer means a number. Yeah. Okay, decimal. Oh, my bad. Hold on. So integer means a number and not a percent. So if they give you a percent, you have to take that decimal and move it twice to the left to make it an integer. Okay, a decimal has a decimal. Yeah, okay, that's obvious. And it's not whatever the number they give you as a percent. So if they give you a percent, you have to take the decimal and move it twice to the left. Okay, the last thing they might tell you to type in is something called a simplified fraction. That's what it sounds like. It's a fraction. But the fraction is reduced. Like you divide the top and the bottom by 2. Or you divide the top and the bottom by 3, or something like that. So integers are whole numbers, decimals have a decimal, simplified fractions, you have to write down the smallest possible, and then always, you never type a straight percentage into your answer box. if you want to type a percentage into your answer box, there better be a little percent symbol next to your answer box. That's the only time you're going to type a percent in. All other times you have to move the decimal twice to the left. Okay, later we're going to talk about something called an impossible event. And that means it'll never, ever happen. Like, in my house, the probability of having fake cheese in my refrigerator because I have high cholesterol, the probability of having that fake cheese is a 0, or it's impossible, because it's never ever gonna happen in my house because I like real cheese. Okay, so an impossible event is something that will never ever ever happen, and you can just say the number 0. Okay, a certain event is something that is 100% gonna happen every time. As in, let's go back to my house and my kitchen, okay? The probability of having fake cheese in my kitchen because of high cholesterol is 0. It's never gonna happen. But the probability of having, let's see, caffeine. Oh, let's say the probability of having some old, nasty vegetables, like that have already gone bad. The probability of that happening in my house is 100%, because we can never seem to eat all of our vegetables. So we always have them go bad, and then we always have to throw them away. It happens every single time. So that's called a certain event. Okay, now let's talk about a deck of cards. Here's a deck of cards. Some of us don't know this. Decks of cards have face cards. They're the ones with the faces on them. The king, queen, jack. Oh, okay. These little looking, flower looking things, these are called clubs. Whoa. Yeah, they kind of look like a clover, like a leaf. These pointy looking upside down heart things, those are called spades. Then of course we have hearts, and we have diamonds. The red ones are easy to remember. The black ones I always have trouble with. Okay, and then we have number cards, and then we have face cards. We already talked about this. Okay, so let's go back to the actual notes now that we know kind of some basic vocabulary. Okay, so 9.1 is about probabilities. The first thing I want to talk about are what an element is. Like if I'm talking about all the vegetables in my refrigerator, the elements would be bell peppers, onions, lettuce, that kind of thing. Okay, let's look at this. It says the elements of the alphabet are, okay, well, what's inside the alphabet? The letter A, B, C, D, blah, 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 all the way to X, Y, Z. Those are the elements of the alphabet. I put ... because I got lazy and I didn't want to write everything. Okay, so those are the elements in the alphabet. Then it says there are blank elements of the alphabet. So that means how many letters are in our alphabet? Well, there are 26 letters. And that's something that's supposed to be common sense, but we forget about it all the time. Okay, let's look at this next sucker. Think of the numbers 1 through 10. There are blank elements for the numbers 1 through 10. Those elements are blank. Okay, well, let's see here. Those elements are the numbers inside 1 through 10. So 1, 2, 3, 4, blah, 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 blah. 8, 9, 10. I ran out of room, so I just put dot, dot, dot. Okay, now how many of these numbers are there? 1, 2, 3, 4, 5, 6, 7. What did I miss? 8, 9, 10. There's 10 in here, if you count what I did not write down from the dot, dot, dot. Okay, so it says there are 10 elements, and the actual elements are 1, 2, 3, 4, blah, 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 blah. Okay, now it says there are blank elements in the set of even numbers, 1 through 10. Those elements are, okay, so what are the even numbers in between 1 and 10? 2, 4, 6, 8. Who do we appreciate? Okay, and how many of those are there? 1, 2, 3, 4, 5. Okay, so the elements for the even numbers between 1 and 10 are 2, 4, 6, 8, 10. And there's actually 5 of those. Okay, let's look at over here to the right. It says event A, or if they just have a capital A, that describes the outcomes from a specific experiment. An experiment can be spinning a spinner. An experiment can be tossing a coin. An experiment can be looking at some cards. Or an experiment could be giving you a vaccine. So, experiment involves like some sort of action. Something happened. Okay, example, it says if event A represents obtaining an even number from the spinner, the elements in event A are, okay, so here's the spinner, and where are the even numbers? 2, 4, 6, 8. Okay, so those are 1, 2, 3, 4 total elements, and then the actual elements of event A are 2, 4, 6, 8. Okay, and I'm not going to write down the number 10 because the number 10 is not in this spinner. Over here on the left, when we were doing that problem with the 10, we included 10 because they said 10 in the problem. 1 through 10. Okay, let's look at this next sucker. It says if event F represents obtaining a factor. Oh gosh, we don't know what factor means. Okay, let's see here. The word factor kind of has to deal with prime and composite. Factors mean the numbers that can divide, or the multiplication facts. So for example, let's say I wanted to know the factors of 12. Well, the factors of 12 are the numbers that can divide into 12. Like 1 and 12, 2 and 6, 3 and 4. Those are the factors. And this is not a fraction, it's just I ran out of room. This was supposed to be a blank. So all these numbers are factors of 12 because it's the numbers that can divide into 12 evenly. Okay, so let's go back to this. It says if event F represents obtaining a factor, okay, so factor means the things that divide into 15. Let's think about the numbers that divide into 15. 1, 15, 3, 5. Okay, but cross out the ones that are not on the spinner. 15 is not on the spinner. Darn. So we can't include that. Okay, it says if event F represents obtaining a factor, blah, 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 the elements in event F are 1, 3, 5. So those are the elements. And there's a total of 1, 2, 3 of them. Yay! Okay, let's keep going. A sample space is the letter S, and it describes all the possible outcomes. So, like, if we think back to the alphabet, all all the possible letters in the alphabet are A through Z. That's also called the sample space. Or this 2, 4, 6, 8, 10, that's the sample space of the even numbers 1 through 10. Okay, so let's see here. And also, a sample space is a smaller portion of the population. So, let's say we were talking about Texans. Texans is not the sample. Texans is the populations. Sorry, the population we're talking about. Whereas the sample would maybe be just the people in Paris. Yeah. Or the sample would be just the people in Greenville. So population represents a big old piece of information, and a sample is a little bitty piece of that same information. Okay, let's look. It says, in event C, the vowels of the alphabet. The sample space is, well, see, the alphabet is the population. It's the big amount of information. But we want the vowels, the small amount of the alphabet. So let's see, the vowels are A, E, I, O, U. And the homework might make you put these little squiggles in. Yeah. They come from, here's the enter button, they come from right here. These are the squiggles. I'm not sure if you need that though. Okay, then the next one says there are blank elements in the sample space. Well, how many are there? 1, 2, 3, 4, 5. 5. It says there are blank elements in the event C. Okay, well, that's the same thing. Event C is the vowels of the alphabet, and there's still 5 of them. Yeah. So we had 5 in the sample space from this list, and 5 from the elements because it's the same as this list. What? Okay, let's look at this next sucker. It says probability of an event A. It's either a ratio that looks like 2 semicolon 3, or a fraction, say 2 divided by 3. Yeah. Or maybe a decimal of 0.67. Or it could even be a percent of like 67%. Yeah. So all 4 of these numbers represent a probability. Okay. Not only that, all probabilities are in between 0 and 1. Now you must be thinking, but hold up, that percent was bigger than 1. You're correct. However, we never stop at a percent when we type it in our homework. Every time we get a percent, you're probably going to have to move the decimal twice to become 0.67. And then heck fire, yeah, that sucker is in between 0 and 1. Okay, now to find the probability, you're going to take, here's the formula, but I like to think of the part over the total, as in a small number on top of a big number. If you get it upside down, you ain't going to get the right numbers. Okay, and then it says we need to reduce fractions if possible. Or means add all of your possibilities. Not means everything else. Okay, let's look at this example on the left. And this is what your homework is like. It's just a straight copy and paste. Alright, it says, the spinner shown is spun. Assume that the size of each sector is the same. Okay, this is the only way that probabilities work, is if when you have a spinner, all the slices of the pie are the same size. If I would have had a circle like this with 4 slices and they're not the same size, I mean, technically I could find the probability, but it would probably be jacked up because they're not the same size. Okay, so let's see here. It says find the probability. Okay, P parentheses factor of 15. Capital P means probability, as in we're going to do the part over the total. Factor means numbers that multiply up to 15. Well, what numbers can multiply up to 15? Or what numbers can divide into 15? 1, 3, 5, and 15. Okay, but if we look at the spinner, 15's not on there. Okay, so now let's come up with the probability. It's the part, which how many of these are there? There's 3 numbers that I just wrote down. So I'm going to say 3 over the total. How many total sections are from this spinner? Well, 1 through 8. There's 8 total. Okay, so the probability of a factor of 15 is 3 over the total, 8. Yay! And we cannot reduce that because nothing will divide into 3 and 8. Okay, now let's look at a multiple of 3. Uh-oh, that's another word we haven't talked about. It kind of has to do with prime, composite, neither, that kind of thing. The word multiple means when you have multiples, like 25, 50, 75, 100. These are all multiples of 25. It's kind of like the multiplication facts. 25 times 1 is 25. 25 times 2 is 50. 25 times 3 is 75. Or let's say we're talking about the number 6. What are the multiples of 6? Well, multiply up. 6 times 1 is 6. Then 12. Then 18. 24. Yada, yada, yada. Yada, yada. Yeah, okay. Woo! So let's go back to that problem. Multiples of 3. Okay, the multiples of 3 are 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. Okay? Cross out what's not on the multiple. Cross out what's not on the spinner. Goodbye, 9. Okay, how many do we have left? We have 2 elements left. So my probability is 2 over the total, 8. But then I think you can reduce it by 2. And it becomes 1 over 4. Hey, that's what you need to type in. Okay? And you're going to type this in if it says simplified fraction. If it says decimal, then we could use a decimal. Okay, the next one. The probability that something is even. Okay, well, what are the numbers that are even from this spinner? 2, 4, 6, 8. Okay, well, how many is that? That's 4 things over the total 8. And then you can reduce that by dividing by 4, and you should get 1/2. Yay. Okay, let's look at the next sucker. 5, 3, or 2. Okay, well, how many is that? That's 3 things. And how many total numbers are from the spinner? 8. So we have 3 over 8. And you might be thinking, hold up, that's the same answer as part A. It's okay, that can happen. We can have the same answers. Okay, let's think about this. Probability of a 10. Well, is 10 even on the spinner? No. So we use that vocabulary that we talked about at the very beginning. If it's never gonna happen, we write 0. Or you might see the word impossible. Okay, let's look at the next sucker. It says composite. Well, composite means numbers that can be divided by 1 and the number and some extra numbers. Okay, so what from this spinner can be divided by 1 and the number and some extra numbers? Well, 4, 6, and 8. Everything else cannot be divided by any extra numbers. Okay, so how many elements are there that I just wrote? I just wrote 3 things. So it's 3 over the total elements from the spinner, or the total amount of sections from the spinner, which is 8. And this is the 3rd time we got that answer, but it's okay. Alright, last sucker. It says neither prime nor composite. Okay, well, I think we talked about that at the very beginning. We talked about what prime and composite was. Neither is just the number 1. Okay, so neither prime nor composite means the number 1. Okay, is that number 1 on the spinner? Heck fire, yeah. Alright, what's the probability of getting this number on the spinner? Well, this number happens 1 time on the spinner, and there's 8 total sections. Woo! Okay, let's keep going. Let's look at this right-hand sucker. It's talking about socks. It says, suppose a drawer contains, I need to write this down, 4 blue, 5 black, and 3 white. Okay, let's find the total. The total is 4 plus 5, 9 plus 3 is 12. Alright, let's see here. I kind of missed this part A. I think I deleted it, but my bad. It says find the probability that the sock is black. Okay, so we're going to do the part over the total, or the small over the big. Or, let's see, how many black socks are there? There are 5. How many total socks are there? 12. Hey, that's our probability. Alright, let's go to the next one. Find the probability that the sock is blue or white. Okay, up above, we said that or means you add up all your possibilities. So, let's see here. The blue is 4. Add up. The white is 3, and that makes 7. Okay, now we're going to do the probability. So, if you're asking why did I add those, because it says blue or white. Or means add. So I took the blue 4 and the white 3, and I put a plus sign. Okay, later on we'll learn a different word besides or. That means we do something else. So that's why I pointed out that word or. Okay, anyway, so the probability is that 7 over the total, 12. Alright, next sucker, find the probability that the sock is green. Okay, well, do I have green? Nope. That's never gonna happen. So we can call it impossible or 0.